Okay, so today what I would like to go over is orbital diagrams. This is another type of electron configuration, and there is information we can get this from this that we cannot get other ways. So when there's this rule is called Hund's rule, and this is another rule we have to follow when we're writing orbital diagrams. And what this says is that when you have a sublevel, you place one electron per orbital before you start pairing them up. And this is also called the empty bus seat rule. So here is the P portion of the electron configuration for the orbital notation. The first way of writing this is incorrect. We have 4 electrons. What we see is each of these lines represent an orbital within the P sublevel. So we're putting electrons and pairing them up within an orbital within the sublevel before each orbital in that sublevel has 1 electron. The second way, we're putting 1 electron each orbital within the P sublevel before we start pairing them up. The second way is the correct way to write that portion of our electron configuration. So I want to show you guys how to do electron configurations with the worksheet that is on Google Classroom. So we're going to do some of them together, and then I want you to do at least half the problems then on your own to get the hang of this. So let me bring up that sheet. So here we go. This is the orbital notation. So let's start by doing phosphorus. So I'm going to write down phosphorus has, let's see, it has 15 electrons. We're still going to follow the diagonal rule. So we're always going to start with 1s. And within the 1s sublevel, there's only 1 orbital. So there's only going to be 1 line. Underneath that, we're going to write 1s. There's 2 electrons in that 1s. So we're going to put 2 arrows. You can either put an up and a down arrow. I like to put half arrows instead. But do not do something like lines or dots, because remember that the electrons have opposite spins. We're representing those opposite spins with an up arrow and a down arrow. And if you made those arrows look the same, that would not fully represent those opposite spins. So after 1s comes 2s. There's also just 1 orbital in the 2s sublevel, so we just have 1 line. There's 2 electrons. We've used 4 electrons. We still have 11 electrons to go. After 2s comes 2p. There's 3 orbitals in the P sublevel, so we're going to put 3 lines. You notice here I have less space between the P orbitals than I have between the 2s and the 2p. So make sure you make the spaces pretty clear. You notice I'm putting 1 in it first before I fill them up. Now we've used 10 electrons. We just have 5 more to go. After 2p comes 3s. So I'm going to put 2 electrons in that. And then after 3s comes 3p. We have 3 more electrons to go. According to Hund's rule, I'm going to put 1 electron in each orbital. I don't have any more, so it's not, I cannot pair them up, and that is 15 electrons. It would have been incorrect for me to write them like this. So that's not the way to do it. This is the way to do it. Okay, so let's do another one. Let's do krypton. So krypton is in the 4th period. So it has 36 electrons. So we start out with 1s, 2s, 2p, 3s, 3p, 4s, 3d, and then it ends in 4p with 6 electrons. So that is its configuration. Just so you know, there is no shorthand orbital configuration. I know these are very time consuming. Make sure you're doing some of these, half of the problems on the sheet, so that you can get the hang of this. If you have any questions about this, please email me.